All right, folks, we are doing question 15. So just want to point out to you, this is section 6.1 in the book, which is just turning probability situations into variables. So kind of looking at the most basic skill here. If you take a look at the formula sheet, there's a probability and distribution section. These two formulas come straight out from chapter 5. So anytime you're doing sample space or a tree diagram, you want to be using these guys. And then down here, this is a section that's for chapter 6. So we're doing discrete random variables right now, and we're going to be looking at this guy. We're going to develop sort of the understanding what that is. So for this diamond insuring situation, we have a chance of theft, which means you've lost your $25,000 diamond. And we have, so you literally, if you're the person who owns this object, it's gone. Okay. And then 80% chance you don't lose it. Now, so from the perspective of the person buying the insurance premium, the expected value, the average outcome, is going to be, the formula says the sum of the product of the probability, how much the event is worth times the probability of the event. So what we're doing is we're saying negative 25,000, 20% chance, and then 0, 80% chance. So that's how that works. So you're multiplying these and then adding them all up. So this is going to give us a negative 5,000 outcome for the person who lost the diamond. So if you lost the diamond, the idea with an expected value is it's the expected outcome per turn. So if you're paying some premium every year, the idea is every year, on average, you might lose $5,000. This is never going to happen. You're either going to lose $25,000 if you lost your diamond or nothing. But this is sort of a per year situation. So if you're the insurance company, you would now like to make it so this person doesn't feel like they're losing $5,000 a year. You want to ask them to pay a premium and balance it out. So the idea, so this is from the customer's point of view. And then if you're the insurance company, and by the way, there's a whole field of study and work called actuarial science, where this is a lot of what you do is you do research to figure out how to balance things out to make these situations work. So from the insurance company's point of view, if this person pays a premium, there's a chance they might have to pay $25,000 to that person, but there's a chance they just get to keep the premium, right? So we would like to, from the insurance company's point of view, charge this person some amount, C. I'm going to make an algebra expression out of this. So the person either pays you C 80% of the time, or they pay you whatever the C amount is, and then you pay them $25,000, and that comes out to 0.2. So what we want to do is we want to make this equation work out so that when we do negative 25,000 plus C times 20% plus C times 80%, they're saying we want the expected gain for the company to be $1,000. So we're trying to solve this guy. Okay. So if we do this, we're going to have to distribute negative 25,000 times 0.2. Okay, so this is negative 5,000. I distribute plus 0.2C plus 0.8C equals 1,000. This is what I'm solving. So if I add these, I get C equals 6,000. So this is saying if you'd like the insurance company to make $1,000 per person, on average, per person who buys the policy, they need to charge each person $6,000 per year. That's kind of a lot. But I think it's because your chance of losing the diamond is so high. It really is probably much lower than that.